Okay, this is number 65 in chapter 5 here. It says find the measures of all the angles in the diagram. And so, since this is an isosceles triangle, if angle D is 35 degrees, then we know angle E is 35 degrees. Then if we want to find angle C, we can use triangle sum and say 180 minus 35 minus 35 is 110. And then since these are vertical angles, it's also 110. And then the leftover is 70 degrees, is split between A and B since it's an isosceles triangle. So this is 35, and this is 35. So there's part one. Part two, make a flowchart showing the triangles are similar. Okay, well, you can basically pick any two angles you want to match up here. All we need is two pairs. So how about angle D is equal to angle A. And so that was because of triangle sum. And then let's do angle DCE is equal to angle ACB. And that's because they're vertical. So take those two pieces of information, that those angles are the same, and that allows us to say the triangles are similar. So we have ABC, triangle ABC, is similar to triangle DEC because of angle-angle similarity. So that's part two. Part three is Sherry and Roberta. Notice their similarity statements for part B were not the same. Sherry stated ABC is similar to DEC, which is what we had stated. Roberta says ABC is similar to EDC. It was correct. Well, they're both correct, because since it's an isosceles triangle, these angles are interchangeable here, right? So D could match up with A, but D could also correspond to B. E could correspond to B, E could also correspond to A. So depending, if this, one of these triangles had like a rotation in it as it was flipped over, maybe A matches up with D, maybe A matches up with E. It really doesn't matter in this case because they're isosceles triangles. If they were not isosceles triangles and these angles were different measures, then you'd have to be very careful about making sure you match up the correct angle with the correct point there. If you have questions or comments, feel free to leave them.